Hey everyone, welcome back to the channel. So today we are diving into one of the most powerful and frequently asked topic in SQL, which is ranking window function. And by the end of this video, you will know exactly when and how to use various ranking window functions like row number, rank, dense rank, etc. So let's get started. So let's see what's the agenda for today's discussion. So we will start with a quick foundation what window functions actually are. Then we will go one by one through all these five window functions: row number, rank, dense rank, entile, percent, rank. So what are window function? As mentioned here, a window function looks at a group of rows and compute a value for each row without merging them into one. So this is one of the defining feature for window function, which is that unlike group by, so when you will start understanding all the various window functions, you will see that group by collapses your rows. But when you use window function, you still see every row in the result, and the key clause here is over. This is so basically there are three different types of window function. If we see the broader classification, one is ranking window function, second is for aggregate, and third is for analytical function. If we see for ranking window functions, we have row number, rank, dense rank, etc. And if we see for aggregate, then we can have sum, average, etc. And if we see analytical window function, then we can see functions like late, lag, etc. However, the topic for our consideration here is only in regards to ranking window function, where we will see row number, rank, dense rank, then entile and percent rank. So what a window function actually is that it looks at a group of rows. So by saying that it looks a group of rows, it means that we can also have partition or window. Basically it makes a window for particular rows, and it computes a value for each row within that particular partition. So you will get more clarity on this definition in the next slide when we will see row number. But for now, you just try to understand that it looks a group of rows within a window or a partition, and then it computes a value for each row. It may be a rank, it may be a row, it may be like dense rank, etc. Now coming to the syntax of window function, this is the syntax: function name, it can be row number, it can be rank, it can be dense rank, entile, percent rank. So in syntax, this is function name that we will write at the starting, followed by over. This is a mandatory clause. It defines the window frame. Then we have partition by, on which column we want to partition. You will get more clarity on it in the next slide. So for example, there are 5 employees in 2 departments: 3 employees in sales department, 2 employees in IT department. So we can have a rank of these 5 employees on the basis of salaries, like from 1 to 5. But say if we want to make the ranks within their departments, this is where partition by is very useful. So it divides rows into group, but unlike group by, where it only provides the aggregated sum for the particular column, window function have all the rows intact even in the final outcome. Here none of the rows will be lost during the SQL query. So this is one of the important feature of window function. Then this is order by. So it defines the order within each partition for ranking. Since here we are interested for row number or ranking, so we essentially need to provide order by on which column we want to do that ordering or sorting. So this is very important. Then we have over. This is mandatory clause, as I mentioned, and it defines the window frame. So now let's come to row number. This one is simple but super useful. It gives every row a unique sequential number. like 1, 2, 3 within each partition. So we are discussing one table. The name of this table is employees. There are 5 employee names: Alice, Bob, Charlie, Dinah, Eve, and they are in either sales department or IT department, and this is their salary. So this is our original table, and we have to find the row number for these employees within their department. So that's why we will use partition by here on the department. So if we write this query as per the syntax that we have discussed in previous slide, this is how we can write. Select the columns which we want in our final result. We want name, we want salary. Then this is exactly as per the syntax that we need to write here. Row number, then bracket over partition by department. So DEPT means department here. So this is a partitioning by role. It will make the window two windows, one for sales, one for IT. Then order by salary, and within each partition or within each window, it will sort the salaries in descending order, and then it will provide row number within that particular window. And in the next window, in the next partition, the row number will again starts from 1. And this is the alias name that we can give. So this is the row number, row underscore num, that this is the alias name that we have given for this particular query, and from employees. So this is our final query, and if we run this query, we will get this row number corresponding to Alice. We are having row number 1 because we have done the order by on salary in descending order. So Alice is getting first rank, Bob is getting second rank, and Charlie third rank. Since we have done partition by here, and partition by for your understanding, it is not a mandatory clause. You can also do the row number without partitioning by on departments. For example, you are just interested to find the row number basis the salary for all these 5 employees irrespective of their departments. So in that scenario, you will not see this here. You will see that this will get 95,000, this will get first rank, and this will get second rank, this will get third rank. But here, since we are doing partitioning by on department, the row number is assigned within that particular window or partition, and in the next partition the row number is again starting from 1. The row number always returns unique value even for ties. So this is very important, and this is one of the defining feature of row number, that even if for example if Bob would also had 9,000 salary, then Bob will get row number 2 instead of 1. So there is nothing like ties here when we are using row number function. So no two row number can get the same number. This is very important, and this is very useful for pagination. So if we see common use cases for a row number, we can have pagination, or we can use it to fetch top and per group. Then deduplication, it keeps first row per group, so it also useful for removing duplicates. Then assigning unique IDs after partition. So for example, we want to provide unique IDs, so row number is unique, so we can also use row number to assign unique IDs after partition. Now coming to rank, so this is again a very important function, and it get interesting because when you start understanding the differences between row number, rank, and dense rank and their application, you will be able to correlate them with the real life practical use cases that where we have to use row number, where we have to use rank, where we can use dense rank, like that. And one of the defining feature of rank is that here ranks are skipped, unlike in the previous slide where we see that row number doesn't skip any number. It provides a sequential number like 1, 2, 3. Here for the same, so the table is same for our discussion here. This is the table. There are 3 column: name, department, salary, 5 employees, and 2 departments. These are their salary. Now we want to assign ranks to these employees, and rank function assign ranks with gaps when there are tied values. You will be able to understand this when I explain you this particular example. So first of all, let's write the query as it is. So instead of row number, we will just use rank here. Like in the previous video, we have used function name row number here. Here we will use rank. And here we are not using partition by, but for now we are just using order by. As I mentioned, that partition by is not a mandatory clause. We can also use rank function without the usage of partition by. Here our entire table is a window. Like in our previous video, we were using two partition, one for sales department, one for IT department. Here entire table is our one partition or one window. So what we are doing, we are interested to find get name, salary in the final output, and ranking over order by salary. So we are sorting these names in order of salary in the descending order, and this is the salary rank alias name that we are giving. So here it will be salary rank from employees. So if you see the final output, this is the output. Alice is having the highest salary. So Alice is getting rank first. Bob and Charlie, they both are having same salary. So both are getting second rank. This is the defining feature of rank, that unlike row number which will assign 2 to Bob and 3 to Charlie, rank is giving 2 to both these Bob and Charlie. So this is the main feature of rank function. And Dinah, instead of getting third rank, is getting fourth rank. Similarly, Eve is getting fifth rank. So here rank 3 is skipped and both the tied rows get rank. Now next rank jumps to 4 instead of 3. Now we will basically most of the people get this confusion that where its application. So if you see sports leadership board where tied players share the same rank. So assume that there are three players playing in Olympics, and first two players have scored same, so they both have secured first rank. But third employee can't be treated as rank 2 because he's not second rank. He's ideally a third rank. So first two players will get first rank, but that third player will get third rank instead of 2. So if we see the output, we will see that there is no player in these three players who is getting rank 2. First two players are getting rank 1 and third player is getting rank 3. Rank 2 is skipped. So this is the most important or most useful example that we can take to understand the application of rank function. Sports leadership board where tied players share the same rank. Similarly, sales competition with equal scores, there also we can use rank function. Now dense rank. This is like the rank with no missing number. Same idea, ties share the same rank, but the difference here is that there are no gaps. After two people tied at rank 1, the next person will get rank 2 and not rank 3. This is the important example that I have taken from Olympics. So it assigned ranks without gaps. Tied rows share rank. They share the same rank like in rank function, but next rank increment by 1, unlike that skipping of the rank when using rank function. So the syntax is same, exactly same. There is no difference. Select name, salary. So in place of rank, we will just replace with dense rank. Over here again, we are not doing partition by. Order by salary, descending. DSC stands for descending here. As dense rank, this is the alias name of the column that we are adding from employees. So this is our final query, and if we run this query, you will see this is the output. Alice is getting first rank, Bob and Charlie are getting second rank, but Diana is not getting fourth rank. Like here, Diana was getting fourth rank. Here, Diana is getting third rank. And this is the difference between rank and dense rank, that dense rank doesn't skip any rank. Similarly, Eve is getting fourth rank. This is correct. Then this is the comparison that we are seeing here for these salaries. So if we use rank function for first three, this is same. rank and dense rank, they will give same output. But for this 65,000 employee, the employee whose salary is 65,000, if we use rank function, it will provide us 4, whereas if we use dense rank, it will be 3. This is very important feature of or difference between rank and dense rank. So you should basically understand this in very much detail. This will be more clear to you when we will do the application of these in detail. But for now, just try to understand that this is the defining difference between rank and dense rank. And similarly, like we use mostly rank function in different scenarios, we can use dense rank mostly in academic grading, like first, second, third place, where we don't skip any rank. Similarly, product categories ranking in e-commerce, where we are not interested to skip any rank. Because for example, you want top three products, then in that scenario you might skip that third rank because you have provided rank 4. So this is basically the application. Now NTILE, it is a completely different from others. Instead of ranking individual rows, it divides your entire result set into n equal sized bucket and tell each row which bucket it belongs to. So in this example, we are using NTILE of 4. NTILE of 4, it means it will create 4 quartile. The highest earner falls into bucket 1, the next group into bucket 2, and so on. So basically what it will be doing, you will get more clarity when I will illustrate using one example. But this particular function is perfect for customer segmentation. You should first understand that where we use NTILE function. Customer segmentation, percentile, grouping for performance reviews, A/B testing, where we split user into test group. So for example, any company can divide its customer into 4 categories based on their spending. We can have top 25%, next 25%, next 25%, and lowest 25%. So this is about NTILE. I will illustrate one simple example at the end of this presentation so that you get a more clarity on NTILE function. Finally, percent rank. This one gives you a relative rank as a number between 0 and 1. First row always gets 0. The last row always gets 1. In between each row gets a decimal showing where it stands relative to everyone else. So this is percent rank, and the syntax is similar to what we have seen for row number, dense rank, rank, and NTILE. You just replace function here as for percent rank, and you will see this is the output. So the result is always between 0 and 1. So 0, Alice will get 0, Bob 0.25, Charlie 0.5, Diana 0.75, and Eve 1. This is the formula. You can also see this formula for your understanding, and this is percent rank is really useful when you want to find top 10% of performer or compare a student score to the rest of the class. So in short, if I say that percent rank shows the relative position of a row in the data set expressed as a value between 0 and 1. So this is all about percent rank. Now coming to a quick comparison, the key rule for all of them is that you always need an inside order by inside over clause. That is the key rule that you need to understand for all these 5 function: row number, rank, dense rank, NTILE, and percent rank. However, partition by is optional, but you can use it if you want to rank the rows within each group. But if there is no need, you can skip partition by. It's not a mandatory clause, but you always have to use order by inside over clause. So this is a quick comparison for all these function. Row number, it always provides unique value. It doesn't has gap, so it's not applicable because it always provide sequential number for like 1 2 3 4. There is nothing no case of ties, nothing is skipped, so this is not applicable. And this is best for pagination, deduplication, etc. rank. TIE share rank. It has gaps and output can range from 1 to n. It sports leadership board that I have explained you using Olympics example. Then dense rank. Here TIEs also share rank, but it doesn't have gap. If two employees have shared first rank, then third employee will not get third rank, that will get second rank. Output range can be 1 to n, and it is useful for academics, grading, etc. Then we have NTILE. It is used for bucket assignment, and this is not applicable here. Again, output can range from 1 to n, and this is useful for segmentation like A/B testing, etc. Where, for example, you want to find your top 25% products. Any e-commerce company might be interested to find the bottom 25% products, so you can segment all your entire product categories into 4 buckets, where first bucket will be called top 25% product, then second and third will be called next 25, next 25, and last bucket can be called as last 25% bucket. Then we have percent rank. So this provides the relative position of a row in the data set, and it is always between 0 to 1, and this is best for percentile analysis. One important thing to note here again, as I have repeated also, all the rank function require an order by inside over. However, partition by is optional and it resets the rank within each group. So if partition by is not required, you can skip it. It's not a mandatory clause. It's a optional clause. But you should have a proper understanding of partition by, because in many of the cases you will mandatorily require to use the partition by clause. So this is the summary again, summarizing what we have discussed till now. Basically just an overview. Row number it always unique, best for pagination duplication. Rank they skip ranks. Dense rank they have ties but they don't have any gaps, best for academic grading. NTILE it split rows into n equal buckets, ideal for segmentation, A/B testing, etc. Then we have percent rank, it returns 0 to 1 relative position, perfect for percentile. So guys, we have discussed theoretical what it's meant for window function, what are different types of ranking function, row number, rank, dense rank, NTILE and percentile analysis. Now we will have one very simple example to understand these function. So for your understanding, I have created this table where there are 5 column: employee ID, first name, last name, department, salary, and then no, this is a different table that I have created. For this, there is a table sales that I have created, and there are 2 columns: product name and total sales. And these are the values that I have inserted. So if you run this query, select star from sales, this is the table that we will be using for understanding. Now I have written all the function in one query so that you get the clarity in single query. So this is row number. I want product name, total sale, and I want to provide the row number for this. So this is how I will use product name, comma, total sales, row number, over order by total sales descending, and this is the alias that I am giving. This is for row number. Similarly, I am interested to find the rank over order by total sales, DESC as rank num. This is for rank number. Then dense rank, similarly, just replacing dense rank here, over order by total sales, DESC as dense rank num. This is for dense rank. Then NTILE 2, we want to do it in 2 buckets, so I'm using here 2 over order by total sales, DESC as bucket. This is for NTILE. Then we have percent rank. So if you see in the syntax, it's just that we are replacing the function name and everything else is same. Percent rank, bracket over order by total sales as percent rank. So this is percent rank. And from name of the table. So if you execute this query, this is the output, and this is exactly as per the expectation. So since we have used in the descending order, this is starting from 4. If we start from ascending, uh, so monitor is having 600 sales. So this is having row number 4, phone is having row number 2, tablet is having row number 3, laptop is having row number 1. So this is how we can see the output of this particular query here.